So I'm sending this video, guys, to make a correction from one of the questions back at the beginning. This is number 4 in the front. My video has the wrong answer in it. At least it's the answer that Mr. Holt, it doesn't have the answer Mr. Holtz wanted because I used the formula on the sheet, this one right here, and I think on your sheet this was even originally marked B, but that's not the formula he wants you to use there, but I used it because that was what was on the sheet at the time. So my apologies. I'm going to go through number 4 again real quick. So you want to find the sum of the first 20 terms there. So the sum of the first 20 terms is going to be equal to n over 2 times a sub 1 plus a sub 20. And now n, because it's the first 20 terms, is 20. So you have 20 over 2. And then the first term, of course, is 55. But what you don't know is the 20th term, and that's where this formula comes into play. But the formula he wants you to use, and that he used to get the answer in his key, is a sub n equals a sub 1 plus d times n minus 1. And so if the first term is 55, and n is 20, we're looking for the 20th term, and d, it looks to me like the numbers there are going down, they're dropping by 8, so it's going to be minus 8 times n minus 1. 20 minus 1 is 19. So this is going to be 55 minus 152. And so if I do 55 minus 152, I'm going to get negative 97 for my 20th term. So now I have to take that negative 97 and add that to the 55, and then that sum is going to get multiplied by 10. So if I do 55 minus 97, I'm going to get negative 42 there. And then, of course, if I multiply that by 10, I get negative 420. And I believe that's the number you'll see on Mr. Holtz's key. That was not the answer I got in the original video. And again, it was because I used the formula on the sheet, but that is not the one he wants you to use. So I apologize for the confusion. I hope that clears things up. Here's number 18. They ask you to solve the polynomial function using a sign chart, and we have an inequality. So we want the product of x plus 2 times x minus 1 times x minus 4 to the third to be greater than 0. So what we're going to do is we're going to set up a sign chart. You can think of it kind of what I have drawn there as like the x-axis, if you will. And so we're looking at the numbers negative 2, 1, and 4. Those are zeros. So that means like if I were going to plot the points on a graph, those would sit right on the x-axis. Those are our zeros. What he's wanting you to find out is what happens in between those zeros. And the easiest way to do that is to do a test value. So if I want to know what's happening, say, from negative infinity to negative 2, this piece right here, I'm going to pick a number between negative infinity and negative 2. How about negative 3? So what I would do is I would replace x with negative 3 in each place where x shows up. And I don't care what the number I actually get out is. I only care about the sign. So negative 3 plus 2 would be a negative. Negative 3 take away 1 more would also give me a negative. I don't care what the number is. I only care about the sign. And negative 3 take away 4 more. Even if I cube that, it's still going to come out negative because odd exponents don't change the sign. Only even ones do. So a negative times a negative times a negative means this interval would be negative. In other words, it'll be less than 0. So that one's not going to work. Now from negative 2 to 1, what number would I choose? I'd probably choose 0 there. So if I put 0 in, so now I'm looking at a 0 value. That red shows up a little better than the pink. Sorry about the pink. So if I put 0 in, 0 plus 2 is positive. 0 minus 1 is negative. And 0 minus 4, even if I cube it, is negative. So what I've got there is a negative times a positive. That's going to come out positive because those two negatives are going to cancel. Between 1 and 4, what do you say we put 2 in? So if I put 2 in, 2 plus 2 is positive. If I put 2 in, 2 minus 1 is positive. But if I put 2 into the last one, 2 minus 4 is negative 2. And if I cube that, I get negative 8. So that's negative. So I have a positive times a positive, and then I have that negative hanging out there that doesn't cancel. So this is going to be negative. So the interval from 1 to 4 is not going to work. How about a number greater than 4, like 5? So if I put 5 in everywhere, 5 plus 2 is positive, 5 minus 1 is positive, and 5 minus 4 is positive even if you cube it. So this is going to come out positive. So what I know now from this sign chart is that the intervals that give me positive outputs, and that's what I want because this is greater than 0. He did not put an equal sign, so I cannot include the zeros themselves in the intervals for my answers. That means no brackets around your numbers. So the first interval that I got a positive outcome for was from -2 to +1. Then I also got a positive outcome, so I'm going to put a U for union. You could also use a comma there. But from 4 to infinity. Now, you never bracket infinity, and the numbers don't get bracketed unless he puts an equal sign, and then you have to bracket those. So this right here, these two intervals, are your solution to that question. The last two problems are exponential. Typically, when we have an exponential equation, we use a log to solve it, and that's what I would do for number 24. So my exponential expression, I have e to the 5x. So I need to get rid of the 10 before I log this. So I'm going to divide by 10 on both sides to get rid of that coefficient. And now I have strictly my exponential expression, e to the 5x. So if there's a coefficient or if there was a plus or minus some number, you would cancel that out first before you do this next step. So on the other side, I'm going to have 499. Now, what am I going to do here? I am going to, because the base is e, but it wouldn't really matter what base. You can always take the natural log on both sides, and that's what I would do. But in this case, you definitely want to use natural log. So if I say the natural log of e to the 5x is equal to the natural log of 499. So I'm just treating both sides the same. Now, your property of exponents and logarithms says that this exponent, this 5x, can come down and become a coefficient. So this is 5x times the natural log of e is equal to the natural log of 499. Now, the beauty of this is that the natural log of e is equal to 1. If you don't know that, you know it now. You memorize that. The natural log of e is equal to 1 because natural log is base e. And when the base and what you're logging are the same, you get 1 as your answer, just like the log in base 2 of 2 equals 1. So ln e is 1. So that means I just have 5x is equal to the natural log of 499. And now to solve for x, I just divide both sides by 5. And I get x equals, now you could do this in your calculator. I'm not going to. I'm going to leave it as ln 499 over 5. If you look on his key and he has a decimal, that just means he plugged ln 499 into his calculator and divided by 5 there, and that's all you would have to do also. Okay, I caved and did it. It's 1.24 if he has a decimal. Maybe he went 1.242 or 1.243 because I think the next number there is a 5. All right, so number 22, you could use a natural log here because, again, our unknown is up in the exponent, but that's not what I would do here. What I would do here is I would rewrite both sides as an exponent with a base of 5. And the reason I'm going to do that is because 125 and 25 can both be written as 5 to a power. So 1 over 25 is now going to become 1 over 5 to the second because 5 to the second is 25. Now on the other side I have 125. Well, that's 5 to the third. So now what I'm going to do there is I'm going to bring, now the 125 though had an exponent of x, so I have to bring that down. So now I've got 5 to the 3x equals 1 over 5 squared. Now I don't like that I have a fraction. 5 to the second, well 1 over 5 to the second I should say, is the same as 5 to the negative 2. I'm allowed to move this to the top as long as I flip the sign on the exponent there. And so I have 5 to the 3x is equal to 5 to the negative 2. Because these bases are equal, the exponents also have to be equal. You cannot raise 5 to 1 power on the left and use a different exponent on the right and expect to get the same answer. So these exponents have to be equal also. So once you get the bases to be the same, you can set the exponents equal. But again, that 125, because I rewrote it as 5 to the third, and there was already an x as an exponent, I had to use 3x there. Now the 25, I just wrote it as 5 squared. There was no x there. So now I'm going to divide by 3 on both sides, and I'm going to get x equals -2/3. So that's how I would do the last few problems. Good luck today, guys.